Hello, and we are the Einstein group number 39, and we will be doing the laboratory experiment number 5, series connected resistance and their method.
So hello and good day, sir. I am Josh FIRMEZA and I was assigned to do the procedure in our group. So in doing lab experiment number 5, same procedure and simulator will be used just like in uh, lab experiment number 4. So specifically, the first thing that the group should also do is to first discuss with their group members if what value of resistance will they be using in the lab experiment. But they should take note that the numbers should be in increasing manner from trials 1 to 3. And then they should open their Canvas account and look for physics in their courses and look for their modules. And then open the modules and click the laboratory template and the link given to open the PhET simulator. And then they should wait for the application to be fully loaded. So once opened, they will see an intro and lab, but they should click the lab and begin the running the lab activity. So as you can see in my screen that I've already constructed the circuit kit. I did this so that I will exceed on the maximum time given to me by our group leader. So now, but we should take note that we will be using 2 voltmeters later on. So now we will now begin doing our lab experiment number 5. So the next thing that the group should do is to disconnect the the ammeter from the wire on its right, just like that. Take note that this ammeter, the 1 ammeter, you may call this 1 ammeter as the first ammeter that will read the current that flows through resistance. So let's just adjust it. So drag one resistor and connect it or attach it on the ammeter, on the first ammeter. And then connect another ammeter beside the resistor, like that. So these 2 wires will be um, will be deleted for a while since we will not be using it for now. And then let's just adjust like that. So this is how it looks like on a series circuit. So now we will be using 2 resistors in this experiment and two ammeters and 2 voltmeters. After this, place another ammeter beside the ammeter, right? This is already placed on beside this beside the switch for us to determine the total current of the circuit. So now you may able to change the value of the resistors. So for this resistor 1, 10 ohms. In resistor 2, 20 ohms. Also in battery, you may change it on any voltage that you want. Either, for example, we'll use 20 volts. 20 volts. So now, drag your voltmeter and attach its terminals on the voltmeters attach the terminals of the voltmeters on the resistor number 1. And then drag another voltmeter and just set aside first. So V1 will act as the first voltage and V2 as the second voltage. Next, for the resistor, place in its parallel side the second voltmeter and will act as the V2. So attach your terminals over here, above there, and underneath. So now, we may now close the switch and record the data on the table. So now, let's open again the switch. So for the total voltage of the circuit, transfer the terminals of the voltmeters to the both ends of the wires that connects the ammeters 1 and 2. Let's use the voltmeter in resistor number 1. Here and over here. And now let's close again the switch. And now we have 20 volts. So this 20 volts is the total current of the circuit. And that ends our procedure in lab experiment number 5 for series circuits. Thank you very much.
Observations. Resistors are said to be connected in series when they are connected. By the conservation of charge, the current flows through each resistors. However, the voltage drop across each resistor is not equal to voltage, but to its sum. Based on our table and gathered data, we were able to come up with 4 observations. First, when connected to a voltage source and the switch is closed, the source supplies a current in a circuit. Second, the series of connected resistances R1, R2, and the total resistances in the 3 trials are increasing in terms of their values and have the same currents. Third, the series of connected resistances, the values of the currents of R1, R2, and the total resistances in the 3 trials are constantly decreasing. And lastly, the V1s are also subsiding, but the V2s are inversely escalating, which eventually arrive into the same value of voltages throughout the trials.
In this laboratory experiment, we were tasked to verify the principles that govern resistance which are connected in series. We have learned that the resistors are said to be connected in series when they are daisy chained together in a single line. Since all the current flowing through the first resistor has no other way to go, it must also pass through the second resistors and the third, and so on. Then resistors in series having a common current flowing through them as the current that flows through one resistor must also flow through the others as it can only take one path.
The amount of current that flow through a set of resistors in series will be the same at all points in series resistor network. As the resistors are connected together in series, the same current passes through each resistor in the chain and the total resistance. RT of the current must be equal to the sum of all the individual resistors added together. In order for us to verify the principles that govern resistance which are connected in series current, we use pitch simulator current construction kit DC.
The analysis can be divided into 3 various analyses: the resistor, the current, and voltage values. First, the values of the 2 assigned resistor values are seen to be in ascending order, resulting in ascending sums through the 3 trials. This concludes that the addance of the resistor values is directly proportional to the sum resistor values, hence all the ascending lines seen in the graph shown. Regarding the current values, the two values provided by the FET simulator seem to be similar, explaining the lack of one more line in the graph. The lines overlap each other. The sum values are also seen to be in decreasing order, concluding that the addans are directly proportional to the sum values of the current. Lastly, the voltage values. The addans seen through the trial seem to vary diversely, but all sums result in the voltage value 9, which explains the uppermost straight line in the graph.
Andre RELANO, and I was assigned to do the task and conclusion. The main objective of this laboratory experiment is to verify the principles that govern resistance, which are connected in series, and through conducting this experiment, we were able to verify the principles that govern the resistance. Based on our gathered data, tables, discussion, observations, and analysis, we were able to verify that the same current flows through each part of a series circuit. The total resistance of a series circuit is equal to the sum of individual resistance. Voltage applied to a series circuit is equal to the sum of the individual voltage drops. The resistors in series hold the same current, but their individual resistance values causes different voltage drops around each resistor. We also conclude that when connected to a voltage source and the switch is close to the source supply, a current in the circuit and series circuit is divide voltages. Thank you.
Through conducting this experiment, we were able to verify the principle that governs the resistances which are connected in series circuit. So, based on our table and gathered data, we were able to attain our discussions, observations, analysis, and conclusion. In our discussion, we stated the principle that governs the resistances, and we also added how we were able to verify the principle, which is through the use of FET simulator. Based on our table and solvings, we were able to make 4 observations, and as for our analysis, we have stated 3 which is based on our observations, and we were also able to make a graph and give our interpretation. And lastly, for our conclusion, we concluded that the same current flows throughout each part of a series circuit. And we also explained further that what we have understood. So again, I am the validator of this group. I am DIESTRO. Thank you for listening and have a good day.